going on, guys? In this video we are going to see an example of free untapped motion with the initial value problem, and in this particular problem we have asked to find out the equation of the motion. Now let's look at the given information. Here we have the weight provided. Weight is equal to 8 pounds, and also the question is asking determine the equation of the motion if the spring constant is 1 pounds per feet. So we know that K value is equal to 1 pound per feet, and if the weight is released 6 inches below the equilibrium position with a downward velocity of 3/2 feet per second. Now 6 inches below, if it's from above the equilibrium, that's going to be negative. If it's released from below the equilibrium, that's going to be positive. So x of 0 is going to be positive 6 inches, but when we use a pounds system we have to use feet. Now we know that 12 inches is equal to 1 feet, so 6 inches is going to be half feet. And also they have mentioned that this is released from downward velocity of 3/2 feet per second, and if it's upward velocity that's going to be negative, and if it's downward velocity this is going to be positive. So x prime of 0 is going to be positive 3/2 feet per second. Now we have these informations, but in order to find the equation of the motion we have to write this one in terms of second order differential equation. Now we can choose any of these three equations. All of them are equal. Now let's choose this one. If we choose this one, we have to know the spring constant, and also we have to know the mass. Now spring constant is provided in the question, that's 1 pound per feet. Now we have to find the mass. To find the mass we can use this equation, m is equal to w over g. W is weight, g is acceleration due to gravity. So m is equal to w, that's gonna be w is equal to 8 pounds. And when we use foot-pound system, the gravitation is going to be in terms of foot and pounds, like foot and second, right? So here we are going to have 32 feet per second square, right? So this is going to be acceleration due to gravity, and if you simplify this one, that's going to give you 1/4 slug. Slug is the units when we have pounds feet system. Okay, so this is our unit. And now we can go ahead and write our second order differential equation. Now this one means x double prime, d square x over dt square, that's x double prime. Okay, so instead of writing like this we can just write x double prime plus k over m. K is 1 and m is 1/4 times x, that's equal to 0. Now let's simplify this one. X double prime 1/1/4. This 4 flips around and go to the top, so this is going to be 4x, that's going to be equal to 0. And if you notice, this is a linear second order differential equation with constant coefficient. When we have this pattern we can use the characteristic equation to find out the real roots. Now in characteristic equation, when we have double prime we replace that one with r square, and when we have r prime, x prime, we replace that one with r, and when we have x we just plug the numbers in front, right? So here we have 4 in front, so this is going to be r square plus 4, that's going to be equal to 0. Now let's solve this one. R square is going to be equal to -4, therefore r is going to be equal to square root of -4, so this is going to be plus or minus, and then r is going to be equal to, since this is a complex number, we are going to have plus or minus 2i, because we replace -1 with I square. So this is going to be 4i square, so that's going to become 2i, right? Now we know that a complex number is in this pattern, alpha plus or minus beta I, and we can rewrite this one as 0 plus or minus 2i. From this one we know that alpha is equal to 0 and beta is equal to 2. And when we have complex number, our general solution for the differential equation is going to be in this pattern. And there are 3 different cases. We can have equal real roots, we can have different real roots, and we can have complex real roots. But when we have complex real roots, this is going to be the pattern, right? Now let's go ahead and write it in this pattern, but our function is in terms of x of t. So this is going to be x of t is equal to c1 and e power alpha x, and we know that alpha is equal to 0, so e power 0 times anything, that's going to be 0, so e power 0 is going to be 1. So these two e power is going to be just 1, so we don't have to write that one. So this is going to be c1 times cos beta x. In our case x is t, so this is going to be beta t, and also I had to replace this beta with 2 because we know the beta value. So beta is equal to 2t, and then c2 sine 2t. Now initially we had two conditions. When time is 0, x value was half feet, and when time is 0, velocity was 3/2 feet per second. We are going to use this one to find out the c1 and c2. That's how we can write the particular solution for the differential equation, right? Now let's go ahead and plug this. X of 0 is equal to half, and if you plug this one, time is going to be 0 because initial condition, right? X of 0, so if you plug 0 for t values, cos 0 is going to be 1. This one will be eliminated because sine 0 is going to be 0. So we are going to have this one alone. X of 0 is half, so let's replace this one with half. Then we are going to have c1 times 1, and this is going to be 0. So c1 times 1 is going to be just c1. So c1 is equal to half. Now to find out the c2 value, we had to find the first derivative. Now to find before we find the first derivative, let's rewrite this equation including this half. So x of t is going to be equal to half time cos 2t plus c2 sine 2t, and if you take the derivative of this one, let's write it here, x prime of t, and derivative of cos is going to be negative sine, so negative sine, and also inside derivative, because we are going to have a chain rule, inside derivative and outside derivative. Outside derivative is negative sine 2t, but inside derivative is going to be 2, so we multiply this one with 2 times half sine 2t, and then again this is going to be also chain rule, but derivative of sine 2t is going to be cos 2t, inside derivative is going to be 2, so this is going to be 2c2 sine cos 2t, because derivative sine is cos 2t, and let's simplify this one. 2 cancels each other, we are going to be left with minus sine 2t plus 2c2 cos 2t minus sine 2t plus 2c2 cos 2t, and now we are going to use this one. X prime of 0 is equal to 3/2, and if we replace if we place 0 for t values, sine 2t, 2 times 0, that's going to be 0, sine 0 is 0, so this is going to be 0, and here we are going to have 2 times c2, and cos 0 is going to be 1, so 2c2 times 1, that's going to be equal to x prime of 0 is equal to 3/2, so this is going to be 3/2, so 2c2 is equal to 3/2, therefore let's write this one here, 2c2 is equal to 3/2, therefore c2 is going to be 3/4, right? 3/4 is going to be our c2 value. c2 is equal to 3/4. Now we can go ahead and write our final particular solution. So particular solution of this differential equation is going to be x of t. We know the c1 value. This is c2 and this is our c1. c1 is equal to half cos 2t plus c2 is equal to 3/4. So this is going to be 3/4 sine 2t. So this is going to be our particular solution for this differential equation, and that's going to be the equation of the motion, and that's how we do this kind of problems. I hope this helps. Thanks for watching.